office.
I did make copies of the review for you guys. And I just now put it on the canvas because I realized that it didn't get there yesterday. Yay. We got marker donations.
$500.
Makes me happy.
$500 each.
Yeah. So don't say anything stupid.
Yeah, I know.
Wow, you were much more clever than I was.
That's one way to do it.
I just propped my phone up against my purse, so you're like in the whole day.
Oh, yeah, hey, tell me, I'll move over, I have no issues moving over. You ever need a report to say something, I'll move over.
My math lab, you know.
I feel bad, I took this class, I took similar class when I
I'll do that.
freshman year. And I had a friend who said, why are you recording? And he was like, I didn't even realize it till the end of class, I just looked at it just the back of your head.
No.
He's like, it's literally just the back of your head and then hearing the voice over again, and I'm like, I was like, why did you say it? He was like, I really didn't even notice.
Yeah. You're just like in the corner of it, it's so big.
Oh, yeah.
And the only voice you hear is like my stupid voice asking questions.
Yeah, I don't remember the way, just tell me how it goes. And you're not even gonna be nice about it, you're just like, hey, get out of the way.
Hey, big boy, get out of here.
Exactly, exactly.
All right, so I meant to have this as a handout, and I just didn't get quite ready to print it, but it's okay. It's only about 7 or 8 problems here that we're going to do anyways. And this is the meaning of a logarithm, okay? So basically, you guys have, just as an example here, 3 squared is equal to 9. I think everybody in this room knows that, right? 3 squared is equal to 9. Well, this is equivalent to saying that log with a base of 3 of 9 is equal to 2, okay? So basically, what the definition of a logarithm really is the exponent. So you have log base a of x is equal to y, is the same thing. So in math, if you take an arrow to both sides like that, it kind of means they're the same thing. It's a long-winded term for definition. That means that a raised to the y is equal to x. Okay, so a couple of things to note about logarithms. One is that the logarithm is always the exponent. And to change from a logarithm back to an exponential, we're not really going to solve anything. These are equivalent statements. We're going to write it like this. 6 raised to the second power is equal to 36. So I think, again, most people in this room know that 6 squared is 36. But if you see how that works, it's kind of a motion that looks an awful lot like, well, is anybody wearing Nike shoes here today? But you see how it kind of looks like a Nike swoosh suit? And I use that term a lot because it helps you go from being a log back to an exponential this way. See how you got 3 raised to the 4th power is equal to 81. And all of these are true. We're not doing any solving or any kind of calculating. We're just rewriting this. And again, I like to use this little, I don't know what you can call it, what you want to, maybe a fish hook or whatever floats your boat. I tend to look at it as a Nike swoosh because it looks that way to me. 14 raised to the minus 2 is equal to 1 over 196. And these are all true statements. One more here. I'll let you write these down. 289 raised to the 1/2 is equal to 17. Again, those are all true statements. So take a look at that. The good news is the test that you're taking on Tuesday will not have these on there. These will be on the final, but I do have the review ready to hand out as soon as we go over a few logarithms and just finish up that homework, then we'll get to the review. But just take a look at those and write them down and see. There's one up here, you can see 3 raised to the second power equals to 9. Sometimes it's good to do that little swoosh thing. Yeah, so you can kind of see how it works. those are our just equivalent statements. We haven't, I mean, the technical word for it is rewrite as an exponential. I quite often say things like swoosh it, because swoosh it, but technically I should say rewrite as an exponential, but by saying, things like swoosh it, it kind of brings back to memory maybe the operation. Anything that jogs the memory is good for me, so. Now, there's a couple more here. Underneath it. Where we have the exponential written, and you want to rewrite this as a log. Okay, so basically what you do here, I mean, there's always a couple ways to think about everything, but what I would do is, and it's kind of in my mind for at least a minute here, there's two ways to look at it. I'm going to write log with these mental boxes right here, and I'm also going to tell you that the exponent is always the answer to a log. The log is an exponent. Okay, so what's the exponent here? 1/2, that will always be right here. And then you can say the base is 64. And then this part right here is referred to as the argument. We know in English that means one thing. Don't try to put English and math definitions together. There's just nothing about it really getting matter. It's called the argument. Okay. But the way I do this is with the mental box there, is because that way you can come back and check and say, does this little circular motion type thing work? Is 64 raised to the 1/2 equals to 8? Is that what we have right here? And the answer is yes. So that's why I kind of use those mental boxes there just to check. After a while, you'll stop using the boxes and you'll just get it. But when you first go to do it, for instance, right here, just write the word log, put in a base, put in an argument, and put in an answer. What do you know the answer of a log is always what? The exponent, so this has to be what? 2, and then the base is going to be 12, and then the argument will be 144, and just check it, 12 squared is 144. You can see how that works. After about 2 or 3 of these, you'll stop making boxes and you'll just write it, right? Because this will be what? Log base 9, 1/81 is equal to -2. See how you can mentally see it now? Just put these boxes in your mind and you can see it. And over here we have log with a base of 112 and 1/144 is equal to 2. That was kind of hard because the fractions are this way. And right now that's about all we're going to do with logs. In the homework we're just going to do a bunch of this flipping around. There's a couple of things about logs that are important to know, worth mentioning here. So log base A of x, A has to be greater than 0. Can't even be 0, it has to be greater than 0. And also, A is not equal to 1, because 1 raised to any power will always just be 1, right? So having a base of 1 is just trivial, right? It doesn't do anything. So that's another thing. Also, x has to also be greater than 0. Now it can be 1, of course, but it has to be greater than 0. So we have lots of positive things happening with logs, a whole lot of non-negative stuff happening here. So negatives and logs don't play well together at all. However, the exponent, the answer, y, now y can be anything it wants to be. And as you can see, there's a couple here where y is -2, and I think we saw one on the other ones too. But notice that everything else that you see in here is all positive numbers, and non-1 for that matter. So that's kind of an important factor right here. Okay. So that's pretty much all that I wanted to use this handout for. Let me go to the homework and show you how we're going to deal with this. We'll have to calculate a few things, but we're going to sign in. I am just running behind today. Look at this. Hang on a second. That's what that duo thing is, in case you're wondering what that is. You guys will all have to do that, I think, in this fall, right? I'm not sure. And they start to make everybody do that, even the students. Well, just to show you, while I have this up under files, the review 3 is here. I think that's it right there. It says, what is it so cheap? It says part A because I did make a part B at one time, but you don't need it. Test is just on that part, so ignore the part A part. it's just the review 3. Okay. All right, and I have a copy of it here anyway, so we'll get to it. But I want to go into Pearson here and finish that homework real fast, and then we'll do the review. Hello, Pearson. How are you? I feel like moving in slow motion today for some reason. Maybe because it's kind of like Friday. Our Thursdays or Fridays are. Yeah. Okay. So when we were doing the homework yesterday, we were working with exponential equations, and that's the lead up to logarithms. I think logarithms start here. Let me make sure of that. Oh, no, that's what we have to do too, but we'll come back to that. All right, here we go. So this is the first part of it, so it's actually 14 where it starts. And if you take a look at this, it's not hard to do at all if you just remember what we just said. Let me erase the board. All we're doing is changing this exponential back to a logarithm, just like we just did here, okay? So you should have enough information right now to be able to do that. Just looking at the definition here. So what you do to write this in to Pearson is you write the word log, and it'll turn bold just by writing it. So see, I'm just going to type L a little bit. When I type the G, watch how it turns bold like that. See how it does? Then you want to have a base. So the base is done with a subscript. And the base here, they've kind of got it written backwards in a way. I would have wrote 2 to the 4th equals 16. Of course, 16 equals 2 to the 4th is the same thing. But what's the base? Well, the base is 2. 2. And then move over. Don't use the raise to, just move over. And what is the argument? Well, the argument is 16. So we'll do that. And remember, the logarithm is always equal to what? The exponent, so what must be 4 here. Does that make sense? That's all you have to do. So it's not scary at all, right? It's just changing. Now, logarithms do get a little weird, but let's just take the good while we have it here, okay? So this would be log with a base of, well, in this case, it looks like A, right? The argument is 3.4, and of course, equal to the exponent of 7. Just a few of those here. Log, what's the base in this case? 4. So you got an argument equal to the exponent of x. Okay, this one's important to note here. There are 2 logs that have special names. First of all, you write the word log, and it should have a base, right? If you write the word log with no base written there, then it's assumed to be 10, okay? So log base 10 is just written as log with no base whatsoever. If you look at the front of your calculator, you'll see log, right? And the inverse to log would be 10 raised to the x, which is right on the top of the word log. You see that? So that's why you know that it's log base 10. Then there's another one where we have a log that has a base of e. Remember e, this number right here? We talked about it yesterday. It's a 2.7 thing by that French mathematician Euler. Log base e is called the natural log, and it's just represented by ln. And that's also in the front of your calculator. We use this a ton in math. That's one of the most used logs there is, for sure, is the natural log. Notice that you can write log base e or you can write ln, but don't put an e on the ln. The ln has the e and it's just ln, 2 letters, that's it. Natural log. So the reason I said that if we take a look at this problem right here, so if I was to rewrite this as a log, I would write log with a base of e of 10 is equal to x. Of course, what does log base e equal to? ln. So this will be rewritten now as ln 10 equals x. Same thing happens when you type ln. It'll give you a bold thing, also regular L, and then also, well, kind of bold, a little right at the back. But see how fat about there? ln of 10 is equal to x. I believe you can also write log base e if you want to, but you should get used to writing ln because we're going to use that a lot. All right, and in the next couple of ones, we're going to do what we first did and change these back. So if you just kind of follow my mouse here using this, what, swoosh type thing, what would you write here? Anybody want to say it? A raised to the what? 9th power, and it's going to be equal to 5. Exactly. So you guys are all experts at logs now. So this would be 4 raised to the x is equal to 16. So now, when you see the word ln, you want to do this. Remember that's log base e, right? So what's the base for the ln? E. So this is e raised to the x is equal to 9. Okay. So at this moment right now, you should feel comfortable with taking a log and rewriting as an exponential, and then taking an exponential and rewriting as a log. You probably and should be asking, well, why does anybody want to do all this? There's a really good reason, and we'll get to it, but it's probably easier if you just learn how to do it right now, and then we'll talk about the why in just a little bit, okay? But in this particular one, we now have an equation to solve. So to solve an equation with a log, generally speaking, we're just going to change it right back to an exponential. So I have 2 raised to the 5th power is equal to 2x plus 3. There's one catch though with these equations. Remember, everything on this side has to be positive. This side does not have to be positive, but everything with the log. So when we're done and we get an x, we've got to check it to make sure it doesn't cause a negative in here, because if it does, we can't use it. So in this case, it's not going to, but it does happen sometimes. You get, especially if what's in here is a quadratic, right? You know, a quadratic has 2 answers. One might be negative, and it's not the fact that the x is negative, but then when you plug it back in, it makes this negative. That's what we have to watch out for. In this case, it's not going to be a problem, but we'll have to do, okay, so 2 to the 5th is 32. That's 2 times 2 times 2 times 2 times 2. I know it's 32. Is equal to 2x plus 3. And we'll just solve this as normal, so it's 29 is equal to 2x is divided by 2. So x is equal to 29 over 2. I'm going to go ahead and take, let's see, is that right? Yeah. 29 over 2 in here. The 2's would cancel. That'd be 29 plus 3 is 32, and 2 to the 5th does equal 32. So the answer definitely is 29 over 2. You see that? And it didn't cause any negatives or anything, so it just worked out perfect this time. So 29 over 2. Okay, so here's another one. I think you guys should try this one on your own. Let me write it over here too, so everybody can see it. It says log base x of 100 is equal to 2. Should take you just a second, really. You do it in a couple seconds, but I'll give you a moment here to try and see if anybody can tell me what the answer is. The answer is 10, yes. But if you do the equation, what happens is you do this swoosh thing here, you get x to the 2nd power equals to 100. And then to solve that, you take the square root of both sides and you put plus and minus, and you get x equals to both plus and minus 10. Which is true for this equation, right? Because 10 squared is 100 and minus 10 squared is also 100. However, this is a log, so what do I have to say about the negative part? Can't use it, so the answer is only 10 as you said. I think that was Elliot, was that Elliot who said that? I looked at my factor or whatever, and I thought it was reversed. Okay, so this one might remind you of what we did yesterday to solve this equation. We're just going to do the standard, whatever you want to rewrite as an exponential. If you want to have fun and say swoosh with me, you can, just, that doesn't transfer to other math classes, okay? Swoosh is not an official math word, it's a Metcalf word, okay? So, funny story about that, though. I have to tell you a funny story about it. Me, I love to tell stories, right? So, what was that? Time to wake up. 4 to, so we have 4 raised to the 5x plus 2 is equal to 256, right? See that? 4 raised to that 5x plus 2 equals 256. Now, how do we solve an equation like that? Well, do you remember what we did yesterday? 256 can be written as 4 to the 4th power. How do I know that? Well, look at the paper. Remember the paper with all the squares on it? Does anybody else need to sign this?
I don't have the paper with the one handed out yesterday.
Right. I'll show it to you right here on the board, but you should, have some of it kind of memorized now, but not all of it or anything. But take a look at 4 to the 4th power. Just so you can see 4 to the 4th power right there is 256. See it? So, it's helpful that I know that because I'm a math teacher, of course I know stuff like that, but it would be helpful for you guys to know that because then you can rewrite this as 4 to the 5x plus 2 is equal 4 to the 4th power. That was the ghost knocking that on my hand. He's like, no, that's wrong. 4 to this, 4 to that. So that means we can strike the bases and say that 5x plus 2 therefore must equal to 4. And that's a pretty easy equation to solve. So we're going to subtract 2 from both sides. 5x is equal to 2 divided by 5. And you get 2 over 5 for the answer. But remember, this is a log, so let's just check it. 2 over 5. 2 over 5 would become 4. And, well, I guess I didn't really necessarily have to check this. So maybe you should check all your answers, I guess. But when it's on this side, it can be negative, right? Even though it turned out to be positive. We still always want to check working with logs because, for instance, here we'll have to kick some numbers out sometimes, or we can't use. And it's interesting, but sometimes the positive numbers will we have to kick out depending on the equation, but usually it's not. So we would get 2 over 5. Okay, so let's rewrite this now as a log. You should try this before I do it. This is e to the 5x equals 3. I'll write it bigger here so everybody can see it. E raised to the 5x is equal to 3. So what you should do is rewrite that as a logarithm and see if you can solve it for x and leave it in terms of the natural log. So hopefully you wrote the word. Well, this is a little more than I would do. You could probably take out some of these steps, but because maybe the first time you saw logs, let me just go ahead and so I kind of started with this mental box. E is my base, raising it to the 3rd power. Remember the power to,
Power is 5x.
Yeah, sorry, that's what I meant, 5x. And not the answer to a log is always the exponent. I just got through saying that in the argument of 3. So that's kind of the way that I would start, but most of you probably would have went straight to this, right? The ln of 3 equals to 5x. I don't know, because this is ln right here, right? Log base e. So I'm not sure if you can go directly to there yet or not. If you have to stop at this interim step, it's no big deal, right? Just take a second, but after a while you'll skip that and you'll go straight to this. And is that solved for x? Not really. You want to divide both sides by 5. And I would take this answer here, which is the ln of 3 divided by 5, and I would write it as 1 over 5 times the ln of 3. There's a reason why. I can't explain that to you just yet because it's going to be in the next section. And all we're going to do is just keep it simple today with logs before we get into the review. But because this now is out front, I can actually move it as an exponent, but we haven't got there yet, so let's not talk about that just quite yet. But that's my motivation for writing it as 1/5 and not the whole thing divided by 5. So 1 divided by 5, and then the ln, was it 3? Okay. Can I answer any questions on that one? Okay, good.
Would this still accept, like ln 3 divided by 5?
Yes, it would. It absolutely would. There's some things that get a little weird though. You gotta be careful the way you write that too, because if you wrote ln 3 divided by 5 like this, that's fine. But if you write the ln of 3 divided by 5, it might think you mean the ln of 3/5, which is different than the ln of 3 divided by 5. That's another reason why I like to get that as far away from there as I can, just so there's no question. You see what I mean? But yes, it would take this right here for sure. Later on, we're going to learn that we can take this number and put it up here. So I could have actually wrote the ln of 3 to the 1/5, which I know you don't understand yet, so I don't want to show you that just yet. But that's another motivation for putting the 1/5 out front, because it's now a factor that I can raise up. Let's do that one again. I want to see if that works actually. This is just me having fun. So, okay, so the answer to this would be what? 1/3 the ln of 2. Can you guys, just if you try it again, you'll see that it'll be the ln of, what? The ln of 2 is equal to 3x, right? And then you would divide by 3. So technically speaking, for Elliot, let's do yours first. So it'll be the ln of 2, and that whole thing divided by 3. It should take that as well. Let's see. Yeah. Now what I'm going to show you here is I'm going to do another one. This will be the ln of 7 divided by 4. Okay, so if you write it my way, and I'm not going to put it in, so 1 divided by 4 times the ln of 7, right? Like that, that's the answer. But now what I'm going to do is I'm going to raise this. It may get really mad at me, but this is also true. I'm going to raise this to the 1 divided by 4. We're going to take this out in the front here, and if this works, you'll understand why I did, although your answer is correct, it's not in the correct form. Okay, so in other words, they won't let me do that yet. But did you see how they said the answer was the same value? So this is a form that we're going to learn how to do. It's what Pearson's telling me right there is, hey, that's the next chapter. Don't be doing that here, okay? So I just wanted to check for myself. So I'll go put it, I'll just divide the whole thing by 4. Did you see the way I highlighted that? And then I hit the division button, the slants, whatever you want to call it on here, and there was everything underneath it. Those are some hotkeys that you should learn, because, well, I mean, should, it's an interesting word. You could also just make a fraction here, right? But you know how when you're working on a keyboard, sometimes it's fun not to have to go to the palette and just type something in and make it happen. What I did was, let me show you again how I did that. I wrote the ln of 7, right? And then if I just hit divide right here, it might just give me, well, actually, no, it just works perfectly. So, but sometimes if you type a whole bunch of things and then you hit divide, it just divides the last piece, right? And if you want it to be underneath everything, just hit shift and move over the arrow while you're holding the shift, it'll highlight everything, and then hit the division sign, it'll go underneath everything. So it's just a cool little, cool. I think it's cool. So I'm not sure what you think it is, but it is a convenient tool, okay? Yeah, if I could speak the word cool in with math, I mean, come on, man. Doesn't happen all that often. So, all right, here's another one. E to the 5x plus 6 equals to 14. What we're going to do is say the natural log of 14 is equal to 5x plus 6. Now, I skipped a step there by saying, log base E and all that stuff, right? I went right to this. Can you guys do that yet? It takes a minute to get there, but all I did was write, well, I didn't write anything in my mind. I created these boxes really fast in my mind, looked at the base of E. I know the exponent is always the answer for a log, right? So then I put the other piece in here, and I was there because this is natural log. So I did this mentally. Does that, can you guys, I know you can. Usually though, especially if this is your first day ever seeing logs, maybe you still need to take this step for a little bit. I don't know, I can't speak for you, but I'm pretty sure that it won't take long for everybody to go straight to there. You know what I mean? Just do enough of them and it'll start to burn in. Now, that's not solve for x, so what I need to do here is write the ln of 14, we're gonna subtract 6, and then we're gonna divide off the 5 there to get the x. Now, this is very important. The ln of 14 right here is locked in with each other. So one thing that people tend to make a mistake is they say, now you take the 14 and subtract 6. No, you can't do that. That 14 is glued to the ln. Okay, so the 14 is glued to the ln, you can't subtract 6 from it. That's why when you write it as an answer, sometimes, and I'll do it this time, is I would rewrite that as -6 plus the ln of 14 all over 5. So there's no question that that -6 is not interacting with that 14. You don't have to, you can write it just like this, but if you're going to do that, it might be a good idea to put some parentheses right here so that you're telling the computer that the ln of 14 is the ln of 14 and the whole thing is being subtracted from 6, not because it might look at that and say the ln of 14 minus 6, it might think you mean that, right? And that's not at all the case. That's something completely different, right? So this way, there's no confusion though. You see what I mean? So you can make it, communication is always a good thing. So, right, as long as everybody's on the same page, including the computer software, we should be fine. I'll go ahead and make it, that there, I'll say -6 plus the ln of 14, my brain can't even remember 5 steps there. Oh, all over 6, right? All over 5, sorry. All over 5, that should work. Okay. Here's one for you to try. This is an equation that says log base 3 x squared plus 6. Oh, I forget where that went. So what's the first step? I don't know let you guys do it, but what's the first step? Rewrite it as a exponent, or if you allow me to say this, swoosh it, right? No, that's silly, but just seeing you smile when I say that tells me you understand what I know, what you're doing. And trust me, making any of this fun at all, is helpful. So by saying silly things like swoosh it, yeah, I know, it's silly. And please don't go to another math class and just, oh, Mr. Metcalf says swoosh it. I'll deny it. I didn't do it. No, I won't deny it. I got a funny story about it, by the way. Actually, I have 2 funny stories about it, but let's go ahead and do that. So what did you get when you swooshed it?
3 to the 4th power is x squared plus 6.
Okay, and 3 to the 4th power is 81, in case you were wondering, because you could think about it like this. 3 to the 4th power is actually 9 times 9, right? So it's 81. So we have 81 equals to x squared plus 6. So we're going to subtract 6, right? What's that give me? 75 is equal to x squared. So what do you do next? Okay, right plus and minus. And so x is equal to both plus and minus the square root of 75. Do you agree with that?
5 square root of 3.
I like that one even better, because this is plus and minus the square root of 25 times 3, or plus and minus 5 square roots of 3. What about the negative?
Drop it.
You would think so, because that's what we did before. But if you put a negative inside here, what happens when you square it? It becomes positive. So in this case, even though we got a negative, it looks like it's going into, the left-hand side where these two things can't be negative. Because this is squaring in here, it's okay. Isn't that strange? And you would think that you would drop the negative, and most people kind of do, because you get into this pattern where, oh, the negative doesn't work, oh, the negative doesn't work. That's for sure. But if you look at it with the square and you check it and it does work, then you have to keep it. So plus and minus 5 root 3 is the answer. Although your answer is correct, I mean, use plus and minus 5 root 3. Actually, you know what? I'm gonna put plus and minus the square root of 75, just to see if it says, gets fussy that I didn't reduce it, because I'm curious about that myself. So this is a little experiment for me, that's all. I want to be knowledgeable about that. So this is the right answer, although it's not reduced, right? So I want to see what they say. Although your answer is equal to the correct answer, you do have to reduce these square roots. So good thing I checked that, so now you know.
It says in simplified form.
It does, I know, but what Pearson says sometimes and what they do is always the same thing. And the only reason I did that was because, that's just really taking advantage of the fact that I'm right here so I can check things. I've been really well known to write emails to Pearson and say stuff, and they say stuff back to me. I think they appreciated me, but I don't really get the warm welcome when I call. What's gonna be? Will you shut up? Stop bothering us with doing. I swear that's how I feel, but it's okay.
And keep bugging them, we pay them too much anyway.
That's what I'm saying too. Although they came down on the prices with that shorter week thing. What was it, $70? What did you guys pay? Price
70 sounds right.
It's, yeah, 70 sounds.
Yeah, because last semester it was 120
Yes.
for the same class. Right, you were here. It was 120.
It was absurd. It was.
Yeah, now it's 70. That's way better. So Pearson did something good finally. I mean, that's $50 less, man. So since I'm being recorded, let me just be on record saying, hey Pearson, good job. If you sell that to them or something.
You bastards.
Oh. Gotta be careful of telling stories too when I'm being let's finish this homework up. Okay, what do we have here? 5E. Okay, so it's kind of really important to pay attention here. Whenever you want to solve for an exponent, you've always got some issues. And we've seen exponents that we've solved for yesterday in ways of rewriting it with common bases. Of course, this base is E. Good luck finding another common base with E, because you're not going to, right? I mean, you're not. So to do this though, you always want to get the exponential part by itself first. Okay, so that's the motivation to write like this. E to the 0.5 x is equal to 7 divided by 5. So remember, when you're trying to solve for an exponent, always get the base by itself. Get any coefficients off of there, okay? Now, there's two ways to do this. Right now, you only know the one way, which is to rewrite it as a log. Later on, we can learn that we can take the natural log of both sides, but you haven't learned enough information about that yet. So it's easier right now just to rewrite this as a log. So I know that you could probably skip this step, but I'm gonna do it anyways. The mental boxes are here. And I'm gonna put E raised to the, 0.5 x is equal to 7 over 5, which then you would rewrite as the ln of 7 over 5 is equal to 0.5 x. And I know a lot of you can now go straight to there, but if you can't, go ahead and, take this step, then go straight to there. Now we're gonna solve this for x by dividing both sides here by 0.5. And I like to write this, watch how I do this. The ln of 7/5, instead of writing 0.5, what's that in a fraction? 1/2, right. And when you divide by a fraction, what do? Flip and multiply, so this becomes 2 ln's of 7/5. Which, I'm gonna leave it to you, but that's how they're gonna want it, but just for fun, just for a little heads up of what's coming, 2 ln's of 7/5 is the same thing as the ln of 49/25. I'll show you that in a minute, how that works, but right now we're just stick with the basics, okay? 2 times the ln of 7/5. Not that. 2 ln parentheses 7 divided 5. I used the parentheses and looked down the middle. Yeah, gotcha. I removed the parentheses to make sure that the 5 didn't get on the bottom outside of the ln, so that should look this way. On my calculator, which is going to take me 20 minutes to set up here. I'll just use the old one that comes up here. It has an ln button, so you say 2, and then the ln of 7/5 is going to be equal to this number right here. And then if I say the ln of the quantity 49 divided by 25, it's going to be the same value. And I have to show you why that works next week. Okay, because for this week we're just learning basic logarithms. Okay. There's not too many more, but I think that was the last one for today. Okay, cool. All right, so that's it for homework. What number was it? 8. So that leaves us with 3 homeworks to go, and a week to do them. Week and a few days, right? So we're good. We're in a good spot, especially since the last homework. If you take a look at the very last homework here, look at this. See what I mean? So, and I think we'll go back. Let's see what 10 is. 10 is probably the longer one, but gosh, it just did that again. Does not like me. 10 is pretty short too, right? And then 9 might be the one that's really long. Let's see, 9 is going to be the worst of the 3 to use. So, yeah, this is the long one because, so we have a long homework to go. We've got a whole week to do it, so we're fine. And then 2 really short ones. The 2 short ones are really quick too. So we're in a good spot. Speaking of good spot, let's go ahead and talk about the review. I'll pass it out here. And while I'm doing that, let me tell you a story. First of all, I teach a night class. Lately I've been teaching it via Zoom. When I say lately, since the pandemic, whatever year that was now, I don't even know. Yeah, I've been teaching at a 6 o'clock class at night, this same course. But, via Zoom now, but for 15 years before that, maybe 18 years before that, I taught the night class right in this room, right? And usually people who come to night classes are people who have jobs during the day, right? That's kind of the idea. And this was probably this is really close to when I first started working here too. It was like one of my very first night classes. And I was teaching logs and I saw that symbol and I came up with the word swoosh. That's my invention. Okay, that was me. 15, almost 18 years ago. And no big deal. Myself, I'm like, hey, it's funny, it's a swoosh. And I kept using it, and since it was the very first time I coined it, I just kept using it a lot, because I was kind of liked it, it's like, hey, swoosh, 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 swoosh. And then, at the end of the course, right, or the end of that section anyways, the lady, she sat in that chair right there where you're sitting right now, and she comes over and hands me 3 Nike shirts like this. And I'm like, well, thank you. Kind of weird, but you know, I'm not gonna say no. She goes, no. She goes, I'm the manager of the Nike outlet mall store, and I just want to pay you back for all of your free advertising. Using Nike thing. And she was so happy with herself that, you know, so I was like, oh, hey, so in other words, now I'm sponsored by Nike. No, I'm not, but it was fun. Okay, so here's the second story to go along with that switch before we start this. I have a son. I probably shouldn't mention his name. He's in Nice right now. He's going into 11th grade, but he's really gifted in math. I have no idea why, but he's really gifted in math. And, you know, he's already taken calculus in 11th grade, and he's one of those kids, you know what I'm saying? So, and I think it was, let's see, it was probably 9th grade. It was 9th grade, he was already into pre-calc, and they were doing logarithms, right? And he was asking me a question about it on his homework, and we were sitting at the dinner table. And I was sitting there and I said, oh, you need to change that log to an exponential right there. He goes, oh, you mean swoosh it? And I looked at him and I said, what do you, he goes, yeah, my teacher at school says swoosh it. And I'm like, oh man, I thought that was mine. Somebody else came up with that too, right? No. His teacher was a student of mine.
Oh my God.
She sat in his class too. Went on to become a teacher in Nice. So I was like, wow, that's really gotten around. But yeah, it blew me away. And he looked at me like I was crazy. He's like, yeah, you're lying. You didn't make that up. My teacher made that up. I'm like, yeah, she did. You want to see my 3 Nike shirts? Anyways, sorry for the storytelling. Let's talk about this review. Who goes to Nice here? Anybody? Good, because I don't want you calling him out. You can't miss him. He's got hair as long as mine. He pretty much looks like me. Just a better looking version of me. He is probably going to be coming here next year. Actually, is going to come here in the fall for dual enrollment. That's going to be odd too, to see him in the hallways. Point him out to you guys and then say, hey, go ask him questions. Go ask him. All right. So. All right. Let's not deal with the word problems. By the way, number 2 is the exact same one from the last one that was also on the test. You can ignore that one, okay? If you haven't got that one right by now, as you're not going to, okay? This is the 3rd time you've seen it, okay? It's one of my favorite ones, that's why I put it on there, but I know I meant to take it off or change it, but just ignore number 2, okay? We'll do number 1 and 3 in a minute, but let's just look at some of the things that we have on here first. We have the inequality stuff, right? Remember how to do that? We did that yesterday, didn't we? And then we have the composite stuff, finding some domains and from composite functions, and then also doing the inverses. And do you remember that homework 6, I think it was, that had 2 questions? There they are, the exact same 2 questions. And that's the whole test. It's pretty short. So it's not gonna be too bad. We're gonna do this on Tuesday, although when I say it's short, remember this one right here, 16 is actually 5 questions, you know, and these are tough ones, okay? And you need to pay attention to these because this one's slightly different than what we did on the homework. It's the same idea, but there's a significant difference, and I'll try to explain it. Okay. Can we start with this one? This is perhaps one of the most challenging ones on here in a weird way, because it's really not super challenging as far as calculating, but conceptually, it might be a little bit hard to understand, so let's see what we can do with that. All right, so starting with this thing, we have a demand equation, just like we did before. X is equal to minus 8p plus 176. And it even says here that the price has to be between 0 and $22. Okay, we could have figured that out for ourselves anyways. But here's the difference. The first question says, express the revenue as a function of X. And the homework said, express the revenue as a function of P. The fact that we're expressing the revenue as a function of X, because remember the revenue, this is part A, the revenue is equal to, I'm gonna put revenue for a second here, we're gonna change it to R of X in a minute, but the revenue is equal to the number of items X times the price you sell it for. It says that right in the homework, and what we did was we wrote P, and then we wrote X here as terms of P, and we put that right in for X, and we had our revenue equation really fast, all in terms of P. But this doesn't say in terms of P, and this is why this is harder. So we have to do something different. We have to take this right here, and we have to solve that demand equation for P. And then put this P in terms of X, so everything's in X. Do you understand what I mean? So it's different than the homework, but similar. So the first step here is to subtract 176 from both sides, and then divide through by minus 8. So P is going to be equal to negative 1 over 8x, and I think that's plus 22. Is it 176 divided by 822? Somebody? It should be because the price says it is, but yeah, it is, okay. And so then we have the revenue here is now equal to x times P, where P is this value, minus 1 over 8x plus 22. You see the difference there? It was an extra step that we didn't have to do from the homework, which is to solve the demand equation for P and not use it the way it is. Now everything here is in terms of what? What letters are in here? X, whereas our last time was all P. So this we'll just distribute that X to get X squared plus 22X like that. Okay, let me pause right there. Do you understand what's happening here? We're making the revenue, which is X times P, is the same thing we did for the homework, but the homework said revenue in terms of P, and this one says revenue in terms of X. So that means whatever variables in here for the revenue had only better be the variables over here. See, there's no more P in here. Okay, does that make sense? No more P's. Now this is the answer for part A, right there. So part B says, what is the revenue if 104 units are sold? Remember, X equals to units, number of units actually, and P is equal to price. So what they say, 104 units as an X, we're gonna put it in for this X, and we're gonna put it in for this X. So part B is gonna be minus 1 over 8 times X, or 104 squared plus 22 times 104. And I don't see them asking a whole list of what's the revenue when it's this, what's the revenue when it's this, what's this. So there's really no reason to set up a whole y equals and table, because we'd be just doing a one-off, right? Just one-off and we're done. So just use your calculator normally. Does that make sense? You could set up a table, it'd be kind of cool and good practice, but personally I'd say, okay, if I just gotta do one calculation, I'm not going to go to all the trouble of entering the function and making a table. If I looked down and there was, 15 more part B's that said, what if it is 104, rather than 110, 120, I'd be like, okay, table time, right? Because I'm not gonna do that 15 times. But how many times does it say here? Just a one-off. So put this into your calculator and I can see, Aaron, are you doing it already?
Yeah, it's 930 or 936.
936, okay, and I'm gonna put, actually dollars, because that's what it is, but you don't have to. Okay, so I'm taking Aaron's word for it, but I remember doing this problem a while back, and I think that sounds right. Did anybody else get that same number? Okay. And all you did was put that in your calculator, right? I don't need to show you that. Okay. Part C. Okay. You can see here that this word ends in IZE, and this word ends in MUM. I know it says maximize and maximum, but I want to teach you about the word ending in IZE, whether it's max or min, whatever you say. That's the minus B over 2A part, right? And the one that ends in mum is what? When you put it back in. Make sense? So one way to remember that is by looking at the words IZ and let's call it suffix, right? You know, max and those are Latin suffixes. I'm not an English teacher, so I'll stop right there, but you know what I mean. When look at the suffix IZ and MUM and you can tell what to do. So let's calculate it. And minus B over 2A would be minus 22 divided by 2 times negative 1/8. Okay, so take a look at what I did. Minus B divided by twice A. The negatives will cancel. This becomes 22 divided by 2/8, otherwise known as 1/4. Is everybody okay with that? The negatives cancel the top and bottom, and 2 over 8 is 1 over 4. And then flip and multiply, and you get 88. Now that's not a dollar figure, that's a unit number. So 88 units under this situation, however they came up with that, that's a micro economics class will tell you how they come up with the demand equation. But under this condition, this number of units will maximize the revenue. Now, what is the maximum? Well, we have to take that 88 and put it where the 104 was, right? And it had better be more than this. And that's what's going to make you think for a second. It should, but let's see. So this is, C has 2 parts. So the second part is minus 1 over 8 times 88 squared plus 22 times 88. So if somebody would be kind enough to do that in the calculator.
968.
How much is it?
968.
$968. Notice that it's more than this. Because this is the maximum. It better be more than this. But you might want to stop and think, wait a minute. If I sell 104 units, I only make this much. If I only sell 88, I make this much. What's going on here? Well, the number of units also is controlled by the price. Or more importantly, the price is controlled by the number of units. They're equally entangled. So by selling 104 of them, you've made them too cheap. That's why you were able to sell 104 of them, because you priced them too low. But you're like, well, I'll sell more. Well, you did, you sold more, but you didn't make as much money. Had you kept the price right where it's still tolerable to people, each item's worth more money now, right, for sailing. So this one, in this condition, this is where you want to price it at when you have 88. So that's how prices are determined. You know, trust me, this is a very small scale of what really goes on in business, but this type of thing does happen every single day in business calculating. People sit around and have to set prices, set insurance premiums, the price of a tank of gas, or a gallon of gas. Those things they change all day long. How do you think they're changing? The demand equations. This stuff is happening every single day of our lives. Trust me on this. Okay. Go to Walmart and you see that everything's gone up $1. Tell you what, Publix went up a lot. I was walking through Publix yesterday and I was like, what? I mean, prices have gone up significantly. So anyway, that's another story. Let's move on to part what? D. Okay. So far, is this making some sense though? How it's working out anyways? I know it's a little hard to kind of comprehend the whole thing, but the calculations aren't super hard. It's the concept. But now for part D, can anybody tell me what to do? I want to know what price they should charge to maximize my revenue. I just got through saying something about that, so you should sort of know what to do, but I want to hear it from you guys.
Would you just take the maximum value and divide it by, or the maximum revenue and divide it by the maximum?
Yes, Aaron, you did that is correct. Although That is a very smart way to do it. What the simplest way to do it is to take the number of items that maximizes it and go up here where the price is determined and put it right there. So it would be, the price at 88 items would be equal to -1/8 times 88 plus 22, which is going to be, well, that's what? 11, -11 plus 22, or $11? Which, by the way, is the same thing you'll get if you take this right here and divide by this. Go ahead and look, 968 divided by 88, it'll be 11. Was it?
Yeah. Do you want us plugging it into the original
If you can understand what you just said,
Yes.
I'm all down with that.
Okay.
Here's why that works. The revenue is equal to what? X times P. If we know X and we know P, R, then of course the P will be the division of that. You see what I mean? That's why it works, but they don't want to tell you that. And when you get into bigger situations where this isn't, you know this is a linear equation, right? Right, like y equals mx plus b, y equals mx plus b. When you change this to quadratic or cubic, things like that stop working so well. But in this basic situation, it does. Very good observation, by the way. Did I teach you that last semester?
Probably.
That's
That's probably why I remember it. Then I worked with money for a long time.
Yeah,
so
that's
it's
I got
just-
you. This is the hardest part of this whole problem right here. Okay, so let's say the company has to make at least $680 off of this, whatever you want, this venture. They have an opportunity to make how much? So making 680 shouldn't be hard, right? So what you'll do is you'll take the revenue, this is part what? E. You take the revenue and set it equal to, actually greater than or equal to, but we'll just start with equal to because it'll be between two numbers. Is $680, or just 680 for the math part, anyways, we put the units in when we're done. So the revenue is -1/8x plus squared plus 22x is equal to 680. If you subtract 680 from both sides, we have a quadratic. Have we solved the quadratic in this class at all? Not once. Just about every single day you've come here in this class, you've solved the quadratic. Okay. It's not really factorable. We're going to use the quadratic formula. And something that I'm going to make sure that you have on Monday is what I'm about to show you right now.
Why didn't we make it an inequality?
We will.
Okay.
To find the inequality, we want to find the boundary points first.
Okay.
But you're right, it is an inequality. But to solve it, we're going to just make it an equal sign for now. Actually, I think this one is factorable, but we're gonna find out right now that you guys are gonna be able to do this too on Monday. What is A? -1/8. What is B? What's 2? And C is -680?
Yes.
Okay, well, the answer is 40 and 136. Pretty cool. You guys, anybody have that on the calculator?
Yeah.
You have that?
Where'd you press?
Under
How
program?
do you have it?
I know how he has it. Let me see.
Yeah, just plug in y equals 680.
Oh, I got you, I got you. Did you do it?
Oh, yeah.
I'll show you how to do that. Did you know you can put games on this calculator?
Yes.
Okay. Don't do it. Well,
Oh, yeah, I got that.
if you wanna play games, go to Game Boy, trust me. way better. Or get a
Probably
Nintendo,
not.
get a Switch or something,
Probably doesn't hurt your hand.
but yeah, no, it clogs up the memory and it slows the calculator down. But, and the games aren't really that cool because look at the screen, for real, okay? But it is kinda cool.
Snake is pretty cool.
I have to admit, no, I used to have one on mine, when I was in college, I had an 83 and I had App Stores on it. And I would sit around in class, I would be pretending to watch the teacher, like, beep, 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 beep. It's not a good thing to do, don't do that. And erase that part of the tape, please. All right, so what did we get?
It's gonna cut
40 and 136. Now, what are those values right there?
It's just the unit, so.
Right, because look, X, right? We're solving for X. What is X? The unit sold. What is the question that I've taken off the board? What is the question asking?
You price it at.
The price. So even though we had a cool little program to find us the answers, which obviously this is factorable because the answers are nice, multiply through by 8, and then these will be the factors right here. But we'll worry about that later. How do I change units to price? By using the price function, right? So P of 40 equals, and P of 136 equals. So let's see what it is. 40 would be minus 1 over 8 times 40 plus 22. Well, 40 divided by 8 is 5. Negative 5 plus 22, I think that's $17, right? And 136 would be minus 1 over 8 times 136 plus 22. So what's 136 divided by 8? Isn't that 17? 17 negative plus 22, that'll be $5. So now that we're going to come back and remember this is an inequality, the revenue function looks like this. How do I know that? Because we've studied this. What's the A value? Negative. And what's the parent function? X squared. X squared looks like what on a piece of graph paper? A parabola. So this is a parabola that opens downward. Remember, negative people frown, right? And the price starts out at 0, goes all the way to $22. Somewhere in here is $5.17, the ones that we just found, right? So between 5 and 17, this value up here will be 680 or higher, right? You see what I'm saying? Because this is the 5 goes there and the 17 goes there. I'm not drawing it to scale at all, so let's do it more like that. There we go. So that's how I know to charge X is greater, P is greater than 5, greater than or equal to 5 and less than or equal to 17. So you answer the question like this. And you make it an inequality. Like that.
Now, could you also write it as, do like bracket 5, 17 bracket?
Yes, you could. Now, this is correct. However, in this situation, remember that interval notation is a notation, right? The one problem with this is when you're talking about money, you really want to have that P, so people knows that this is a price interval and not a unit interval or something. This is correct, it is equal to, but when it comes to something like this, I would say this might be better because the average reader could read this. The math person has to read this. Does that make sense? So although he's correct, I would rather this one be used here. But if you did that, I certainly wouldn't mark it wrong. You understand what I'm saying, right? That the P, when you're telling people in business, the mathematician, he can write this, but he's probably going to be telling his managers what to set the price. And if he shows them this, they're going to go, what's that? Right? But if you show them this, I think they can figure that out. Does that make sense? Right? Okay, guys, make sure the price is between $5 and $17 in each of your stores. You can choose anything in there, you're going to make at least 680 or more, and your, what you would call it, customers, so whatever. So as long as you guys are in here somewhere with your price, your business will be at 680 or more. And You know, if that's what you want. Of course, you have the opportunity to make this, right, 968. So most of them are gonna, okay, well, I'm gonna set my price at what? 11. Smack dab in the middle. Why at the middle? Because guess what that's gonna do? And then we find the price be $11 and made the most money. However, what if they set it at 11, and because of their particular region or because of their whatever, who knows what, you know, but each region has different needs, you know, right? Like if you live near a lake, you probably sell more fishing gear than people who live in the city, right? But people in the city still can sell fishing gear. But the people around the lake are probably gonna sell more. So they could probably play with the price. You know what I'm saying? So there's all kinds of different reasons why you would change the price. Most people would go straight for the $11 to make the most money. Which is funny though, because in this situation, I think $11 is the cap, because why would you charge more but still make as less? You see what I mean? That makes no sense to me.
Yes.
But there are reasons why people do that too. And I can't really understand or remember them, but I remember being taught that in economics and still thinking it was weird. But something about keeping the price at a level that's uniform with the whole region, so that your other Publixes, everybody's not leaving that Publix at all to come to this Publix because this Publix is cheaper. You see what I mean? So because if it's one store against another, then all bets off. But if you have a chain of stores, you want to keep the customers going there. So even though one place might be able to lower the price, they won't. Does that make sense?
Yeah.
So, but I'm not an economics teacher, so we can end it there with that. So what do you think? What do you think of that number 16? Can you do it now? It's an awful lot. So that's why when you look at the test, you know, there's only 17 questions, right? But that one right there is like a whole test, though.
That's the
a lot.
last one I'm gonna do.
It's the last one?
Yeah.
Okay. I do that one first.
Really?
I don't know.
Yeah.
Do the highest.
No, I would do the easy ones first. These are the easy ones right here. This is, by the way, Aaron, for number 4 and 5, this is where you would use the integral notation like that.
Okay.
I mean, this is strictly a math question, right? Like, you're not gonna probably ever be out in the street or in a store somewhere and somebody say, hey, x squared minus 5x minus 6 is less than or equals 0. What's the answer? It's not gonna happen. But this type of pricing thing, you might see that in your business life, for sure. You know what I mean? But it's all part of the same game, and these are just training you tools, these 4 and 5. So let's just do those quickly here. I'm jumping around a little bit because I want to get some of the good ones off. I want you guys to immediately scrape off number 2, right? That's not happening. And then I want you guys to go home this weekend and try the whole review. Maybe even write the answers down for, the answers are not there for the last 2 problems. Or 3, look at the back of the answer keys missing, which, because I wrote
Yeah,
it.
it's just like 16, 17.
Okay, so make sure you get the answers for that one written down, so in case you try it again, you just write the answers down and then go try it again, see if you can get them, okay? And if you want to, I can get another one of these too, for you as well. All right, let's do number 4 and 5, because again, these are quick and painless. You have parabola. This one opens upward because it's positive. You have x squared minus 5x minus 6 is less than or equal to 0. I'm going to set it equal to 0. Factor it to get x, minus 6x plus 1. Like that, right? Minus 6 times 1 is -6, and minus 6 plus 1 is -5. Pretty straightforward factoring job. So what are my solutions here? The solution set is +6 and -1, right? So that means that in this parabola, that if I really draw a better representation right here, at -1 and at 6, so let me see if I can draw my x-axis there. So at -1 it goes through 0, and at 6 it goes through 0. Now, notice that in this particular one, I didn't write it in any particular order. It's just this is 2 numbers in a bucket right here, so you can put them anywhere you want to. But now, since I want to be less than or equal to 0, that will be all the numbers in between -1 and 6 is where the function is down here. Now I have to put these in order, And I wanna say -1 all the way to 6, and since it actually says equals to, Aaron, what do I use? Brackets. And notice that this is an infinite set of numbers, and this is just 2. This is from -1 all the way to 6. Whereas this is just 2 numbers. 6, wherever you want to throw those in a bucket, you can. These you can't, because you read from left to right.
And it doesn't matter which form you write that in, you want it in.
Oh yes, you could also write it like this. -1 is less than or equal to x is less than or equal to 6. Yes, you can do that as well. I don't care which one you use here. Was that crazy?
I don't like that
Oh, I thought you might like that one better.
It does.
one. Better than the bracket.
Yeah.
It's like easier to understand it, at least for me.
Everybody's different, I guess. I like this better myself, but I've been thoroughly trained to use this more than I even want to admit to, you know, so I'm totally good at both, you know what I mean? But when it comes down to it, to me, I don't know. I guess I don't know. This just looks better to me. Fits my brain better. All right, so for the next one, notice it's greater than or equal to 0. So what kind of answer is that going to look like? It's going to be -infinity to some number, union with some number to infinity, right? It's going to have that winged look to it, that where it has the U in the middle of it with the 2 things. So, and since it has the equals to sign, it'll be 2 brackets on the inside. So I already know the answer is going to look like this. For this one right here, it's going to look like this. -infinity to some number with a bracket, union with the bracket from some number all the way to positive infinity. All that's left now is find out are these 2 numbers. How do I know that? Well, because this thing opens upward and it's going to hit the x-axis at some 2 points, right? And everything outside of these points, it will be up here in the positives, whereas everything inside these points, it's down in the negatives. Greater than or equal to 4 at the moment, we're going to put the 4 back over so that we have x squared minus 3x minus 4 is greater or equal to 0. That means the solutions to this will be the same as the solutions to this. So all I need is these 2 numbers right here. So I'll just factor this. X minus 4x plus 1.
Why didn't we set this one equal to, or why didn't we set this one as equal instead of not waiting as an inequality? Oh, there wasn't a reason.
Because I just need the 2 numbers. That's all. And what 2 numbers are they? 4 and minus 1. And where do they go? Right here. Can I put the 4 here? No. The minus 1 has to come first. And then the 4. I think I'm going to end class today right there. Because I really want you guys to go home and practice this. We did the composition of functions in class. We did 3 of them yesterday, right? So you should be able to get these done. Then this is defining the domain or the inverse. There's 2 ways to do that inverse thing. So right there on the thing, if you want to make a note. Remember that to take the composition both ways and you get an x, that proves that they're inverses, right? The other way is to simply find the inverse. And the way you find the inverse is you write y equals to whatever, change that f of x to y, switch the x and y, and solve it back for y. Remember doing that yesterday? Try that at home. We'll do it all day Monday for sure. But that's it for today. Hopefully you can catch the bus.
Yeah.